After my presentation from last month, where I presented derivation of the same gravitational relationships that we normally see from general relativity that I derived from Heisenberg's uncertainty principle, I guess I sounded a lot like I didn't think we could go faster than light. And I've been asked this question several times since that video came out. So I thought I would put together some slides just to show, that honestly, I do think we can go faster than light, but doing it is not in any way, shape, or form easy, nor is it, do I know exactly what to do it. But I have, based on my engineering model of quantum gravity, which is, Jeremy just pointed out that once you understand quantum gravity, you have the tools to do the job. I've put together these slides to just show what is required based on my model. And it's not what you think based on other general relativity or Alcubierre or Ontario or anything like that. And this is all based on quantum mechanics and on the quantum harmonic oscillator. And how could we say, in this case, make a quantum harmonic oscillator travel faster than light? So to start, I have an abstract. Here we go. And it's proposed that the gravitational fields may be interpreted as a reduction in the relative available driving power of the electromagnetic zero-point field. It is shown that variations in the relative power are covariant with variations in the coordinate speed of light as measured by a distant observer in unaltered space-time, in other words, distant from the gravity well that he's looking at. Gravitational time dilation and length contraction may then be interpreted as a loss of power from the interaction between matter and the zero-point field. It's hypothesized that for matter to achieve apparent faster than light travel, this process must be reversed. So instead of a loss of power, we need to drive power into matter and increase the total power of the oscillators, thereby stretching the ruler, so to speak, and increasing the rate of the clocks or the oscillators, so that from this frame of reference, the universe appears contracted, and as such, the distance between here and there is shorter. So utilizing the techniques of nuclear and electron magnetic resonance to stimulate Larmor radiation, experiments can be conducted which will pave the way for understanding and creation of artificial gravity, anti-gravity, warp drive technologies, hopefully in our lifetime. So I mentioned the coordinate speed of light, and this is what is relevant. The local speed of light that you measure on a benchtop is not, all right? That is your ruler and clock that you use to measure the speed of light on a benchtop is already scaled to give you a constant speed of light, and nothing you can do on that bench is going to change that. But in terms of space-time, light travels along a null geodesic, which means its path through space-time has zero length. So here we have the metric line element set to zero, and we solve this for the coordinate speed of light, and I refer to it as CK, and we see that it's simply the rate of change in the coordinates squared, and this leads to solving the equation. It leads to the speed of light having a refractive index, K, that sets the speed of light at any point in the gravity well. So as a distant observer looking into a gravity well, he sees clocks slowing down, rulers contracting, and the speed of light is getting slower. Now, from the opposite perspective, if you're down inside the gravity well, again, you've got a bench top, you're looking at measuring the speed of light on your bench, and you get C. It's the same as it was far away. But now, from your perspective down in the gravity well, looking out, you see clocks running faster, rulers are stretched, the speed of light is faster, and power is greater. So this is what I mean by reversing it. So we have to look at things that cause your ruler to stretch and your clock to run fast. And in terms of the polarizable vacuum model, we use K as a refractive index. And so K greater than 1, in this table, I presented this several times before, all these relationships hold, and I can derive these relationships many ways. But if K is less than 1, then the speed of light is faster. Rulers expand, clocks run faster, and in this frame of reference, the distance between point A to point B that you want to travel appears shorter because in the reference frame of the warp ship, it's stretched to like 500 times its normal length. And as such, in that frame, the distance between those 2 points is shorter, and you can travel to it faster than light without actually exceeding the speed of light in your frame. Okay, so next, what I've learned is that the refractive index in terms of the vacuum out there. But inside matter, the refractive index is replaced by a damping factor, zeta squared in this case. And it's related to radiative damping. And so we have the same table, but now we have these values are changed by using the damping factor, zeta squared. And it's the exact same relationships over again. And these come from the mean square probability values from the quantum mechanical harmonic oscillator. And so X squared is the mean square position range. That's the probability cloud of the particle. The velocity is the mean squared velocity squared. This is X squared over velocity gives you the mean squared time period. So that gives you time dilation. And A squared, the mean squared of the acceleration, and acceleration is reduced if the damping factor is greater than 0, or it's increased if the damping factor were less than 0. And then mass, which I explained in my previous presentation, that it's the surprise element that in order for force to remain invariant, meaning that forces we measure outside of the gravity well are the same as what we would measure inside the gravity well. Force and angular momentum don't change. And in order for that to be true, then mass has to change. So your rest mass will increase as it falls into a gravity well. But the key takeaway from these tables is that power and the speed of light both vary covariantly. They vary proportionally. So if the damping factor changes and it decreases the speed of light, it also decreases the power, and vice versa. If it increases the power, it increases the speed of light, and that's what we're going to look at. So as I was saying, these are the from the perspective of a distant observer, it appears the gravity appears as a loss of power in the harmonic oscillators that make up matter. The variable zeta plays the role of a radiative damping function acting on harmonic oscillators and altering their mean square fluctuations. And these fluctuations are the root of what needs to be manipulated. And go back a slide. So we have the mean square position value, the mean square velocity, acceleration, and power. And here it is in terms of the damping function, and here it is in terms of the refractive index of the vacuum. So I prefer the damping function because that's what we are going to manipulate matter. Okay, so where do these relationships come from? These relationships have been derived identically from multiple sources. In my previous presentation from last month, I derived them from Heisenberg's uncertainty, and these are those relationships here in column 1. If you use the Schwarzschild solution of general relativity, you get something like this, and which is also true of the polarizable vacuum model. And if you use the radiative damping model, you get this. And they're all three are different interpretations that lead to the same conclusions. And that just reinforces what I'm saying here. So here's some excerpts from where this came from. And this is Peter Milani's book, The Quantum Vacuum, An Introduction to Quantum Electrodynamics. And here in chapter 2, he shows this equation 2.82. And this is just a regular harmonic oscillator equation. But on the right, you've got E naught and you've got ERR, which is the radiation reaction field. And here are their equations in terms of quantum electrodynamics. So I'm not going to get into the details there, but I just wanted people to know that this is in the text, and that's where it comes from. And the total field acting on the dipole has two parts, E naught and ERR. E naught is the free 0-point field acting on the dipole. It is the homogeneous solution of the Maxwell equation for the field acting on the dipole, the solution at the position of the dipole. And it's satisfied by the field in the source-free vacuum. So this is in the vacuum. You can have source-free electromagnetic fields, and that's what E naught is. And for this reason, E naught is often referred to as the vacuum field, although it is, of course, a Heisenberg picture operator acting on whatever state of the field happens to be appropriate at t equals 0. ERR of T is the radiation reaction field. It's the source field, the field generated by the dipole and acting on the dipole. And using this, we get a slightly different version where he's moved the radiation reaction term to the left-hand side of the equation. And X triple dot here is the jerk. That is the time derivative of acceleration. And as such, it appears as a loss. It's a loss of energy from the harmonic oscillator. And he says that classically, the dipole in a vacuum is not acted upon by any external field. But if there are no sources other than the dipole itself, then the only field acting on the dipole is its own radiation reaction field. But in quantum theory, there is always an external field, namely the source-free vacuum field. And moving over here, the field is in fact necessary for the formal consistency of the theory, and that's the vacuum field. In particular, it is necessary for the preservation of the commutation relations, which is required by the unitarity of time evolution in quantum theory. And, sorry, too far. So we can appreciate further the necessity of the vacuum field by making a small damping approximation. And when you do that, you get this loss in terms of a velocity, which is basically friction. Forces dependent on velocity are friction. So without the free field E naught in this equation, the operator X of t would be exponentially damped, and commutators like position and momentum would approach 0 within a few periods of the frequency. So, but with the vacuum field included, it preserves the commutation relations by holding up the bottom, by setting a baseline for the oscillator. And so if you go back over here to this first equation, 2.82, think of if this right-hand side were 0, that would be a stable oscillator that would go on into infinity. But with radiation reaction, it's losing energy, it's radiating away, and it's decaying, but the 0 point field sustains it. So these two terms on the right-hand side are equal and opposite, I should say. And they basically support each other and cancel it out. So here's another version of it from Hal Putoff. And it's much easier to understand than QED, and that's why I prefer this. It comes from his paper, Quantum Ground States as Equilibrium Particle Vacuum Interaction States. He shows clearly, as did Milani, that the power radiated by the oscillator is balanced by the power absorbed from the vacuum field, the 0 point field vacuum fluctuations. Absorbing energy from the 0 point field is only possible to sustain the ground state. It isn't going to excite it to higher and higher excited energy states. It only is enough to support the ground state. It does not work, to extract tons of energy from the vacuum. However, as I understand it, this is what Brilliant Power and Light's hydrino is all about, pushing hydrogen below its ground state such that it must restore the energy by absorbing it from the vacuum field. Now, they haven't really released all the details of what they're doing, but theoretically, what they're saying matches what I'm saying. That if you can push and lower the ground state energy, then the vacuum is going to replace it. And in that sense, you could possibly extract energy from the vacuum. And let's hope that's what they're really doing, because that would be a major breakthrough. So he goes on to create a generalized approach. And in the generalized approach, he starts with this balanced force equation. And with external force, the Lorentz force, the radiation reaction is equal to the main force, the mass times acceleration. And then he gives this relationship here, which is essentially multiplying this first equation by the velocity. And when he does that, he says, at this point, we recall the earlier quoted statement that derives from quantum theory. The crucial role of the vacuum fluctuations emerges in the ground state of matter. The stability of matter, the stability of the ground state, the fact that it does not radiate, is a purely quantum effect, which is due to the vacuum fluctuations. In stochastic electrodynamics, that's SED, developed, here, we find its expression is positing that application of equation 26 to represent the stationary ground state pre-force requires that the time-dependent second term on the left-hand side must be conjectured to vanish. So this term in the expectation value bracket is 0. And then once you, otherwise, it could not be taken to represent a stable, time-independent ground state. Again, we want the ground state to be stable because that's what it is in reality. Excuse me. As a consequence, the remaining terms constitute the condition that reveals itself to be the average power radiated due to accelerated motion, Larmor radiation, is balanced by the average power absorbed from the vacuum fluctuations. Substituting the definition of lambda previously, we get the same relationship that the power radiated is equal to the power absorbed. And if you look at this, Q times the electric 0 point field is a force that the 0 point field is exerting on the charge. And so that leads to the acceleration, which then radiates it away. And so this is an equilibrium condition. Excuse me, tickling my throat. Okay, so repeating what he said, And rearranging equation 26, I included the time derivatives of the rest energy because, as I said previously, mass changes in a gravitational field, and it also changes in a warp field. It's not constant. And we see here that the radiation reaction term, which is velocity times the jerk to get power, is subtracted from the total power. And then we have this new term that is dependent on the power and energy gained or lost by the particle itself. Just like the rocket equation, that mass is a time dependent function. Excuse me.
Todd, do you want to take a short break if you're having trouble?
No, I'll be all right.
Oh, okay.
Right. So the V external is just an external time-dependent confining potential. So like if I have an oscillator, it's got to be confined by a potential, otherwise it'll just fly off to anywhere. So that's all that is, but it could be a lot of different things. It doesn't have to be a simple harmonic oscillator. The same would apply. The same equation would apply. That was the general approach that Hal Putoff took. So the gravitational potential depends on power loss or gain. And here I'm equating the damping factor with the speed, multiplying by the speed of light squared to get this pseudo gravitational potential, so that you can see that for gravity, if there's a loss of power, and m dot, which is the time derivative of mass, times c squared is less than 0, such that 1 minus the zeta factor is less than 1. But for anti-gravity, it's just the opposite. Key points are the stationary states are time dependent. The time derivative of energy is 0, and the power at equilibrium is flat space-time. There's no gravitational acceleration if your power is balanced all the time. It's when you break that symmetry of power in equals power out, conservation of energy, when you break that symmetry, that's when you get free fall or propulsion. And that's our goal. Excuse me. Okay, so here's the leak. To mimic gravity is something that we can strive for, if not the real thing. But here's the key, and what we can do experiments to test with. This is Newtonian gravity. It's just Poisson's equation, but I included the time-dependent part. And rho is just mass density. And now, as you know from previous presentations, that in my model, I model space-time as a density of scalar magnetic flux. So there are random magnetic flux everywhere with variable density, and they're not polarized. They're just, it's from the gauge potential. It can be considered a gauge potential, but it's there's an infinite number of different possible states you can have, but the key is that it's the sum of these flux quanta that are randomly scattered everywhere. And some could be coherent, some could be decoherent, but that is the background space-time. And so if we do the same thing and exercise Poisson's equation, we get something very similar to what we have here. And if we take these flux and the answer, and that gives us a flux density, and we divide by mu naught c squared, we get a mass density. And so that's the mass density. So we plug that into the first equation, and we get this leading constant 4 pi g E naught. And in terms of the flux alone, as a time derivative, you get 4 pi g E naught over c to the fourth times the square of the time derivative. And you can see that the potential is a second order effect. Because it depends on the second derivative squared. Whereas up here, we have a second derivative of the gravitational potential, where it's the gravitational potential that has units of velocity squared. So it's slightly different, but it leads to the same conclusions and will cause the same effects. So since 4 pi g E naught has units of charge to mass ratio squared, coulombs per kilogram squared, the effects can easily be mimicked by the square of the gyromagnetic ratio, which has a much greater amplitude to work with. And so here we've written it out in terms of gamma, which is the charge to mass gyromagnetic ratio of the particle over c squared. And it has the same units of measure. And this are in every way equivalent. And so this is how you can mimic gravity using things that affect the spin of the particles, like nuclear magnetic resonance and electron paramagnetic resonance. So that's what we'll talk about next. So here's that rearranged power equation. And here is Larmor, the standard formula for Larmor radiation, equated to the power absorbed from the 0-point field. And we see that the mean square fluctuation acceleration is derived or driven by the 0-point field spectral energy density, which you may be familiar with is proportional to frequency cubed. And that's important because only a spectrum proportional to frequency cubed is Lorentz invariant. So no matter how fast you're moving through the vacuum, you always see the same 0-point field. And that's because it's proportional to omega cubed. So the primary hypothesis to derive propulsion is that the mean square scalar magnetic flux density is non-zero and leads to a frequency squared like this using the gamma. And where the average scalar magnetic flux density is 0 because it's a 0-point field. So like I say, those scalar flux are random, they're not polarized, and instantaneously you have a value, but on average, they average out to 0. So the frequency can then be controlled, or hopefully can then be controlled, using applied magnetic flux density fields. And here's a way of looking at that. And you can see here that if we're in free fall, mass, or I should say energy, is losing energy. And so power is being reduced. And so this is a negative, and because this is a negative rate of change, and that's free fall. Warp drive, or faster than light, would require this to be a positive rate of change. So the power is increasing, and increasing the power is what gets us what we want. And so I made some predictions. We now at Falcon Space Lab have 4 people working on this nuclear magnetic resonance and electron parametric resonance experiment. Mark Sokol is working on the EPR Alzaphon experiment, and myself and 2 other people now are working on the NMR experiment, which uses a printed circuit board that I designed specifically for this task. And as I mentioned before, I built a a zero Gauss chamber and purchased several power supplies and Helmholtz coils to try to make an NMR machine that I can actually monitor with enough resolution to detect the weight loss or a force on the material due to this effect. So I've run through the preliminary calculation for nuclear magnetic resonance on a gram of water. So it's 18 grams per mole. So if we had, so 1 mole of water is 6.02 times 10 to the 23 molecules per gram. That's the Avogadro's number. And that would contain 2 moles of protons, which resonate 42.5775 megahertz per Tesla. And if we assume a gradient magnetic field magnitude of 1 Tesla per meter, which is, or 1 millitesla per millimeter, which is not a very large gradient, and if we assume 100% of these protons are polarized and participating in the experiment, then the force we'll get is on the order of 34 millinewtons per gram per Tesla per meter. So 34 millinewtons, which is pretty small, but it's measurable. And I think I can measure that. Now, Mark is working on the EPR experiment. And Alzafon doesn't require a gradient in the magnetic field, but I know that it's required. And it's there regardless. But having too uniform a field may actually kill the effect. But the effect you want is with a gradient of 1 Tesla per meter. And he's going to test a sample that's an alloy of aluminum and iron and some other stuff. But I just used regular aluminum, and I assumed 1 mole of free electrons. And electrons have a resonance of 28.02 gigahertz per Tesla. So 3 orders of magnitude greater. And so for the same gradient in the magnetic flux density, we get 11 newtons per gram. That's huge. And so I think we just found the needle in the haystack here. Is if you can get free electrons to resonate throughout the hull of the ship and throughout the ship and all its passengers and everything together, you can exert an enormous force with a relatively mild gradient magnetic field. Now, the strength of the magnetic field you need to get 100% participation is probably very large, and I didn't make that calculation. But even at, let's say, 40%, it's still huge. So this is the key. This is the equation, and this is the prediction that says that we'll be able to design things using nuclear magnetic resonance, magnets, and RF gigahertz, as has been observed on some of these UAPs, to be able to make craft that can move like a tic-tac. So the critical takeaways here are the vacuum refractive index is less than 1, or the radiative damping factor is less than 0. Power and velocity vary proportionally. So if the power goes up, speed of light goes up, and that's what we want. And a gravitational field is a loss of power. And because it's a loss of power, no work is being done when an object or a person is in free fall. And there's and anti-gravity, faster than the light work field, is an increase of power. And just like walking uphill, work must be done. Work must be done to climb upwards. And that's critical because it requires work to be done to create an anti-gravity field. So anything that thinks you can get anti-gravity from a static field where no work is being done, it's not going to work. You have to have a dynamic field that can do work on matter in order to produce an anti-gravity effect. Okay. So lengths expand in the reference frame of the matter to be transported. Clocks tick faster in the reference frame of the matter to be transported. So those are the things that you need to remember, because in the reference frame of the expanded ship, the universe is smaller, and the distance between any 2 points is also smaller and can be traversed faster in this frame. So increasing the power that determines the scale of matter. I saw a video yesterday that just came out about parametric frequency shifting, where they add multiple frequencies to a quantum harmonic oscillator and cause a frequency shift. I didn't include it in the presentation here, but it was a very detailed presentation, theoretical, of what can be done to cause frequency shift. And I thought it was very relevant. And other things are nuclear magnetic resonance and electron paramagnetic resonance, having a field that can cause these resonators to increase their frequency and increase their power. So, and then in order to have a true warp drive, not just a propulsion system, it has to affect all the matter to be transported. So everything, the people, the passengers, the luggage, whatever you're carrying, has to be caused to resonate at higher power and inflated. And this inflates the scale of matter, and it's a natural effect of the increased power. So when you increase power, matter inflates. Inflating the matter reduces its energy density in a natural effect of the increased power. Volume increases faster than the energy input, equivalent to adding a negative energy density. And we call this inflated matter. And I coined that term back in 2015 when I published the paper, The Electromagnetic Quantum Vacuum Warp Drive in JBIS. So you have an increased rate of the passage of time. Clocks tick faster, resonant frequencies are higher, and this can be driven by an increased scalar magnetic flux density. And that's what, the goal would be in some of these experiments would be to create a scalar magnetic flux density, one that's non-polarized, and show that you can still control the frequency in the same way you would do using a regular polarized magnetic field. And so now here's the thing that's going to raise some eyebrows. And this is what faster than light does not require. And I mean, in this model, and according to my model of quantum gravity, a bubble of space-time moving through space-time as in an Alcubierre drive is not required. A pre-accelerated river of space-time moving through space-time, as in Notario's work, is not required. Violating the strong and weak energy conditions of general relativity, as per Matt Visser, is not required. Exotic matter, something we don't know what it is, or negative energy density, is replaced by inflated matter, because inflated matter, as I just said, when you increase the power, matter inflates, but it inflates in volume faster than the energy you're putting in. So the energy density goes down. And so if you have positive energy density and you add negative energy density, the energy density goes down. And so that's the exact same effect you would get as if you added negative energy density to the positive energy density of matter. And that's critical. And you don't need time travel. In fact, time travel and warp drive, based on this, are mutually exclusive. If warp drive is possible, and I believe that it is, then time travel is not possible. And nothing in the model tells me how I would make a clock run backwards. It only allows me, based on the bombardment of zero-point field photons bombarding the particle, to give it a volume and control its oscillation. Nothing tells you how to run that clock backwards. It's just faster or slower, but never backwards. There's no front or back to it. It's just you're either putting power in, taking power out, but you don't have a system where it goes in reverse. So that's pretty much it.